Hey guys, welcome back. We're back at it and into a new week. So hopefully last week was your first week of doing 3 different teachers for this. Hopefully that went well. I know it can be a little bit confusing. So we as teachers are also trying to straighten that out a little bit because I know like at the end of mine, I give you some problems to do for practice. Okay, and then have the solution. So it's kind of like homework. And then the next day you do the quiz. So we're trying to get a little consistency there. Obviously, if you don't have some problems to do from one of the other teachers, your whole goal is make sure you're taking good notes during the videotaping that they're doing, whether it's the Screencastify or whether it's like YouTube like mine, and then studying that so you can then take the quiz the next day. And I know like on my quizzes, you can take it multiple times, but just don't go taking it, memorizing answers, because that doesn't do you any good. Okay, so we're trying to keep you up to date so you're successful going into next year to the best of our ability. So let's get started. This video might be a little bit longer because area of a circle has a lot of components to it, but I'll try to get you through it without just doing it super fast. So hopefully everything's good. The weather's starting to get a little bit better, and I know I'm happy because golf courses are opening up, so I'll be able to do that on the weekends and that. So we're getting better and better every day. So here we go. Okay, so we're doing lesson 912, and if you notice by my logo here, it says the store was out of area rugs, so I got a circumference rug instead. Ba-dum-bum. Okay, bad dad joke of the week. Question: what did the buffalo say when his son left? Bye, son. Bison. And I like this one. This is the rare and stealthy sofa bison, which is for those of you who can't make that out, that's a cat that's like stretching and its hair is standing on edge and it looks like a bison. So we have that cat at our house that does that. So kind of funny. Okay, here we go. So we're talking about area of a circle, and this is my introduction with pi. This is, for those of you who know, Mrs. Rodenkirk and I, we're math pi geeks. We love Pi Day. It's our holiday or it's our celebration. She does all those cool activities and does pie in the face. I do a lot of pie art around my classroom and that. So it's just a fun day. So this first slide, all you got to do is listen carefully. I'm giving you a little bit of a background. Okay, so it's kind of like reading to the class out loud. Okay, so here we go. It says the ratio known as pi, which is pi, it's pronounced like PIE, was first discovered by the Babylonians nearly 4,000 years ago. Over the years, the Egyptians, the Chinese, and the Greek mathematicians also found the constant ratio between the circumference and the diameter of a circle by using the measurement. The Greek letter pi has been used to represent this ratio since the 1700s. That's how long this has been. This has been for 4,000 years. It's incredible. Okay, when it was made popular by a Swiss mathematician, his name is pronounced Euler. Okay, so just like that. So even though this ratio has been known for many years, the value commonly used for pi is still only an approximation. We still don't have that constant number yet. Okay, and the cool thing, let me move back over here. The cool thing about pi is no matter how big the circle is, okay, that number pi, okay, can be used with all circles. Whether it's the cap on top of your water bottle, whether it's the bottom of the water bottle, whether it's a truck tire, a monster truck tire, a can of fruit, okay, pi talks about the relationship between the circumference and the diameter. Okay, and it will always come out to be 3.14. So when you measure and you do a division, it's always going to be the same. It's kind of cool, kind of freaky how that works, but it works. Okay, let's move on. Sure? Paying attention? Come on, Easton. I know you're probably sleeping back there. Okay. Okay, so now we're going to estimate the area of a circle. So a circle is different from any other shape that we've studied. Okay, because it has no sides, no corners, and it's very difficult to apply any strategy of like decomposing it, making it into rectangles and squares and triangles because of this. So we use estimation as the technique to try to figure out what's the area of it. So we're going to use the first circle with a radius, the distance. Remember radius. You had that in 911 with diameter, radius, and the circumference. So the radius is the distance from the center of the circle, okay, to the outer edges. And we're going to have 5 units, and we're going to do it on the resource page. But how we're going to estimate the area is we're just going to simply count. So let me show you. So here's our circle. So we're just going to count. When we said it's 5 over, the radius from the center is 1, 2, 3, 4, 5. So it's got a radius of 5. But I want to know the area of this. So we're just going to count. And I can go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 62, 64, 66, 68. So I have 68 right now. Now, if you noticed, I didn't touch the ones that had partials. I'm going to try to match them up to make a whole. So I noticed that like this little piece right here could fit in here approximately. So I'm going to count this whole thing as 1. And I'm going to count these 2 pieces as 1. So that's 2. I'm going to count these 2 pieces as 1. That's 3. These 2 pieces as 1. That's 4. So I've got 4 more. I'm going to do the same up here, where we have 1, 2, 3, 4 more there. Now I've still got a little pieces out here. And what I'm looking at is going, this is almost a whole. And this one's almost a whole. So I'm just going to count them as wholes because remember we're estimating. So we're going to add 1, 2, 3, and 4 more. So that's 12 plus the 68 is approximately 80 units squared. So area estimate is 80 units squared approximately. That's what those squiggle lines mean, is approximate. So you should remember that from stuff we've done prior. So hopefully that makes sense. Now that's easy when we have a grid like this, but we don't always have grids like this. Okay, so we did that. Whoops, let's get that out of there. So we don't always have ones like that. So let's go to the next page. And we often get ones that look like this. So how do you count that? So when it's convenient, if they're drawn on grid paper, but often they're not, so we're going to look at the shape a little differently. First of all, it says, how can you find the area of the larger square? What is the area of that? So let's take a look at this. So this is 5. So the radius of my circle is 5. Now, if you notice, if the radius is 5, you should be able to tell me what the diameter is all the way across, because this is going to be 5. So my diameter all the way across is going to be what? Yep, it should be 10. 5 and 5 is 10. So if this is 10 all the way across, okay, then it's going to be the same this way too. It's going to be 10. So I can find the area of this outer square is a 10 by 10, or, okay, area is equal to 100 units squared. I hope that makes sense. So again, this radius is half the circle, but it's halfway across. The other side, halfway across. So 5 and 5 is 10. 10 times 10 is 100. Now, if we look here, it says, how can you find the area of the smaller square? This is a little bit different, a little bit more difficult, but let's get rid of the blue. So if you notice with the smaller square, this is 5, and if this is 5. So notice that I have a triangle here now in the smaller square. If I go like this and make little dashed lines, I have 1, 2, 3, 4 triangles. So whatever I get for this one triangle, I can just multiply by 4. So I'm going to put 4 and then times something. Well, we all should be proficient now in being able to find the area of a triangle. If you remember, it's the base times the height divided by 2. So we have 5 times 5 is 25. So again, we're doing the triangle. Area equals base times height divided by 2. So area is 5 times 5 divided by 2. So area is 12.5. So if we put 12.5 in there, okay, that gives me that triangle. Now I have 1 there, but I need 4 of them. So I don't care how you do this. You multiply by 4, or you can just say, well, this and this make up half of it, so that's 25. Add those two together, it's 50, whatever works. So notice that the area of the smaller square, this one right here, is 50 units squared. Okay, so right now we have 100, and then we have 50 for the smaller one. Now let's think about that for a second. You have 100 for the outer one, you have 50 for the inner one, and your circle is about halfway in between. What would you estimate the circle to be then? If the outer one's 100 and the inner one's 50. Yes, Alexis, thank you for yelling that out. Next time, raise your hand though, please. Yes, she said it's going to be halfway in between. She said 75. So she's saying that here is that this circle she's going to estimate at an area of approximately 75 units squared. So the outer 100, the inner 50, in between 75. And again, we're estimating. We don't have the real one yet. And then it says down here, how does the actual area of the circle compare to the area of the square? Is either square a good estimate? So the 50 and the 75 aren't really good estimates, but working together, it gives us a good estimate about where that circle is. So we have 50, 100, inner part 75. So I hope that makes sense, because that's all the information I have right now. And we don't have that magic formula yet. We're working our way up to there. Okay, so here we go. Okay, so we're on 924 now in your text. So it says, Julia needs to estimate the area of a circle with a radius of 6 grid units. She decides to use the inside-outside average method. So let's estimate the area of the circle with a radius of 6 by counting whole squares and parts. Well, notice I didn't give you that. But if I do go back to here, okay, I could find another one that has 1, 2, 3, 4, 5, 6. You would count them all up. I don't want to count them all up though, okay? So if we do, remember we have 6 here and 6 here, so there's 12 in this row, 12 in this row. If we do that, we have another 12 and we have another 12. Here we only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we have 1, 2, 3, 4, 5, 6, 7, 8. Here we have 1, 2, 3, 4, 5, 6. And then here we have 1, 2. And now I'm talking about whole squares now, not the little parts. And then obviously it's the same the other way. 10, 8, 6, and 2. But then I need these little pieces. So here's one. Here's one, so we have 2 more. Here's a little piece. And here's a little piece. So we have 2 more. Then we have this one and this one. And we have this one and this one, so there's 2 more. We have, I'm going to count this one as a whole, this one as a whole, this one as a whole, and this one as a whole. So there's 4 more. And then obviously whatever I've done here, I can do that on the top part too. So we're going to add, since we had 6, I'm going to add 6 more. So that's 10. So I'm going to add 16 to all those numbers. Again, that's just quick counting. So I have 16, so I have 12, 24, that's 48, 58, 68, 78, 88, 94, so 100 plus the 16. So we're saying this is approximately 116 units squared. Again, that takes a little while. We don't want to use a little while, so let's go back. Okay, so that was A. So now what they want us to do to find the area of the small square, Julia needs multiply the length times the width. So we want small square. We're talking about going. Okay, so we do 6 times 6 is 36, and half of 36 is 18. Inside, first, 18 and 18 is 36. 36 and 36 is 72. So that's the small one. If I want the outside in red, if this is 8 and this is 8, 6 and 6, this is 12 and this is 12, I have 144 for the big one. So I need halfway in between 72 and 144. Can somebody get that for me? I'll give you a second. Good, somebody just yelled out, they added 36 more to this, which gave them approximately 108. Okay, and again, it's approximately 108 units squared. So we're talking about how are we finding this circle to the best of our ability. That's what we're trying to do, and we're using estimation yet. We're not getting totally perfect. So you can count if you have the grids, or you can do the inside square. Inside square here. You can do the outside then square, and then estimate halfway in between. Again, both of those take a little bit of time, but it is doable. But you got to remember how to do a triangle, and then multiply it by 4, and then be able to use the radius and the radius, otherwise known as the diameter. That's that edge, and then you got to go halfway in between. So if you notice, this was the inside that we just did. Okay, we found the inside part, we did the outside part, and where the circle is about halfway in between. So that's what we're talking about here. I kind of summarized it for you instead of going ba-dum, ba-dum, ba-dum. So let's move on. Okay, here's where it gets a little bit fun. We're now going to take that step and show you where does the formula, because I could have just given you the formula right off the bat, and you would have put it there, but you would have had no idea where it comes from and why. So this is our formula to find area of a circle, and yes, you do need to know this. So we have area equals pi times the radius squared. Okay, and we're going to always use 3.14, or if it's in fraction form, it's 22/7 for pi. So if you're putting it on your calculator, you're going to do 3.14 times blank. Here's the reason why we do that, is because if some of you push the pi button and then multiply, and then some of us press in 3.14, we're going to get slightly different answers. They're both good, but slightly different answers. So to try to be consistent, let's just have everybody use 3.14 and punch that in. Now, what I'm going to do is I'm going to pause right here in a second. I need you to do this on your own. You're going to copy this URL right here into a browser. Okay? And you're going to bring up a video on YouTube for where this formula comes from. Now, if it malfunctions for whatever reason, here's what I want you to do. Just go into YouTube, go search area of a circle, and you're going to see it in green. I'll show you what it looks like. So it's going to look kind of like this. I'll start playing this one. It'll start like this, and it draws out. Now when it starts, it's a bunch of green and black. It's usually like the third one listed. So I'm not going to go through this whole thing with you. You're going to do that on your own, okay? So I'm going to get rid of this. I'm going to go back there. So this will give you an awesome idea about where this formula comes from. And it's kind of cool because it shows you how this area formula is almost exactly like that of a rectangle, which is kind of like a square, which is similar to the triangle, but triangles are half of a rectangle. They're all interrelated. And it kind of puts that into perspective, and it's pretty cool. So make sure you watch it. Please make sure you watch it. Okay, so when you're solving these now, you're going to use this formula as we're going forward. So let's go to that. Let's try a couple. Okay, so it's your turn. Okay, this is where you want to pause your video. You're going to write these down in your notebook, give them a try, and then you're going to restart the video, and I'll have the answers there for you. So hopefully this was good for area of a circle, and you'll be good. And then remember, for me, you take your Canvas quiz the next day, which is also pretty much true for Ms. Rodenkirk and Ms. Warzen. You might have a little bit different homework. My kids do the stuff that I have up here, but you get the idea. Okay, so let's take a look at this. So we have this circle at the right. It's got a diameter of 20 centimeters. I want you to use this formula to find me the area of that circle with a diameter of 20. And then for these down here, I want you to find me the area and the circumference. Circumference was in 911. You did that the day before. Find me the area and circumference of these two, and then just find me the radius of that one. Okay, so that's 15 meters there, 9 inches here, and that's 314 centimeters there. So I want the area and circumference of these two and the radius of that. Okay, so I'll let you go do that, and then we'll be back in a second. So we'll pause. Pause. Okay, you're back. Good. So I hope you were successful. Let's take a look at the answers now that you got all that down. Okay, so for the first one, you should have gotten 314 centimeters squared. And if you weren't sure how to do that, all you had to do is, remember, the formula is pi r squared. We plug in 3.14 for pi. You plug in 10, which is the radius, and you square it. So remember, the whole way across is 20. We only want halfway across the radius. So we want just this little piece. So it was 10 squared, which is 100. Times 3.14, that gave us that. Now we have these, where you had to find the area and the circumference. So let's do the area first. That's the easy one. So here, we put in 3.14. We take the radius, which is halfway across, 7.5 squared. So I get on my calculator, do 7.5 times 7.5 times 3.14. And I get 176.6 meters squared. Here, I use the 9, so 3.14 and 9 squared, or 9 times 9. You should have gotten 254.34 inches squared. Now let's go back over here and see the circumference. So for the circumference, if you remember from 911, it was 2 pi r. So you had to do 2 times 3.14 times whatever the radius is. So here you did 2 times 3.14 times 7.5, and you got 47.1 meters. Here, 2 times 3.14 times 9, 56.52 inches. Now this last one's a little trickier. So we knew the circumference was 314. So the circumference is equal to 2 times pi times the radius. So we put in 314 for the circumference. We put in 2 for 2, 3.14 for pi, and r is r. Now we have to solve this equation. So we do 2 times 3.14, which is 6.28. So we have 314 equals 6.28 times r. Now I need to get rid of the 6.28 off the r, so I divide by 6.28. So this is that giant 1. I have my r left. 314 divided by 6.28 is 50. So the radius is 50, and I should have my units, it should be centimeters. So 50 centimeters. So I hope that was successful. So you got some good practice with area, some good practice with circumference, and we're all good, and you're ready to go. Sorry it was a little longer, I do apologize, but information that you did need. Have a good one, and we'll see you next week. Bye.